on to logarithms and what we can do in logarithms. So what you can do in this mode, you can convert logarithmic function into exponential functions. You can convert exponential functions to logarithmic functions, and you can directly achieve the results of logs without changing or introducing bases. All those people who have studied logarithms are aware of the fact that logarithms require lots of calculations and lots of rules to remember. But if you are comfortable with using calculator, lots of rules can be proved and can be justified. So let's say we are first proving the rules of logs through the calculator. I hope people who are in this workshop or the episode are aware of the fact that log a plus log b is log a multiplied by b. That is, if you add two logs, it is same as taking the base of log common and multiplying its power. So I can prove this through calculator. How I will do so is log base let's say log base 5 power 2 plus log base 5 power 3. The result is 1.1133. Please remember this result, 1.1133. As per the rules of log, when the two log functions with the same base, here the base is 5, when two log functions with the same base are added together, it is same as multiplying its power. So let me prove that to you. 2 multiplied by 3 is 6. So log 5 and 2 multiplied by 3 is 6. You will get the same answer, that is 1.133, which is a proof that log 2 plus log 3 is same as log 6. So if you want to prove any logs, all you need to do is you have to make sure that this and this have the same results. So if I write it like this, shift and log, if you note there is log written with yellow here, so I will have to press shift and log to bracket close. So log 2 plus log 3 is equals to 0.77815, and I am aware of the fact that log, if have a positive sign in between, it means that powers are multiplied, that is 2 and 3 will be multiplied, it will give the same result. So I will write log 6 and please check, I will get the same answer. Agreed? Alright, there are the places where log function is found are: number 1, if you want to write log without any base or power, you will press shift and you will press this button, and log with yellow will be considered, and this will be log without any base or power. When log without any base or power is considered, it is log to the base of 10, which is also called LG. Log with a base of 10, which is also called LG, can directly be written by pressing shift and this button. But if you want the log with a base and power, you will press this button where my cursor is. I hope this is visible to all. This button indicates log with a base and power. So if we have a base and a power both, then we can write log from here. All right. The next rule is, if two log functions are subtracted, it is same as dividing the power. So if I write shift log 12 minus shift log 6 and I close the bracket, my answer is 0.30103. Agreed? But if I want to apply the second technique, that is when I subtract the two log functions, it is same as if I have divided the powers. So I'll do shift log 12 divided by 6 and I will close the bracket. And my answer will be same, that is 0.30103. So any log function, any rule of log can be proved through the calculator. See, log 5 and cube is 2.0969. It is same as 3 multiplied by log 5. So if you know the rules of logs, you can prove it through the calculator and check that the answers are coming out same. All you need to do is you need to ensure that you know the rules of logs. As long as you know the rules of logs, you can prove it through the calculator. I hope this answers the concept is clear. Another thing in log is you should be aware of the fact that ln x and e power x are inverse functions of each other. Ln x and e power x are inverse functions of each other. So whenever I write ln e with anything, let's say 3, then my answer will be 3, because ln and e are inverse functions of each other. So ln of e3 is 3, ln of e7 will be 7. Ln of ex, if there is some stored value of x, it will take that stored value. So if let's say the stored value is 5, then the result will be 5. I hope this is clear. Ln e with any power will give the same result, because ln and e are the inverse functions of each other. I hope this is also clear. Another feature of log is that log with the same base and power will always be 1. Log with the same base and power will always be 1. So log with a base 10, power of 10 is 1. If you recall, I told you that when I press shift and this button, this log is basically log with a base of 10. So if I will write 10 here and I will close the bracket, I will still get 1. The log in the calculator without a base means log with a base of 10. Similarly, if it would have been log with a base of 2 and power 2, it would still have been 1. I hope this is clear to all of you. So log with the same base and power is always 1. Similarly, log with any base, power of 1 is always 0. Log with any base, power of 1 is 0. Log with a base of 5, power of 1 is 0. Log with a base of 12, power of 1 is 0. Similarly, if I will press shift log 10, I got 1, because log with the same base and power is 1. And if I press shift log 1, I will get a 0. Similarly, ln is log to the base of e. Ln is log to the base of e. So if I press ln 1, I will still get a 0.